Hey there, this is Brendan Wolf, game sound designer. This video is about how I designed an interactive Foley system using player speed to dynamically adjust the pitch, volume, and timbre of a character's clothing. This was achieved using Wwise and Blueprint scripting for an interactive music platformer that I developed in Unreal called Brubeck Dreaming. I began by recording Foley sounds into Pro Tools using my Rode NTG5 microphone, starting with my backpack for the character's pack jostles, metallic belt buckles, my coat, and my GDC jacket for clothing material swishes. Next, I imported the WAV files into Nuendo and used Krotos' Reformer Pro to create custom Foley libraries sorted by backpack, clothing, and buckles. Once all the libraries were created, the fun part was using Reformer to generate the Foley. So using dynamic input and activating continuous play, we can adjust the playback of the amplitude, frequency, bandwidth, and variations. And then by unmuting and muting the other selections, we can create the different types of Foley. Buckles. And backpacks. Once we have all these Foley sounds generated, we can then start editing them. Next thing you want to do is detect the silence and strip it. So we go to Audio and Advanced, Detect Silence. As you can see here, it automatically will find all the different silence portions and how many sections you process it. And then you have all the different waveforms split out. Okay, there's one final thing to do before importing all these files to Wwise, and that's ensuring that all the new audio clips are properly named according to a naming convention. File name should go from general to specific. In this case, that means that it'll have the type, SFX, the category, FO for Foley, subcategory, SO for source one-shot, the number of channels, mono, the description of what it is, buckle, and finally the iteration number. With this naming convention, I created a CSV file for Nuendo's rename events from list that'll nicely batch rename all the files ready for export to Wwise. Finally, we're ready to export using Game Audio Connect, having already selected the correct container in my Wwise project, and boom, sending it over the fence to my PC. In Wwise, the first thing I did was define the 3 different surface types. So we have grass, stone, and wood. And then for each of those surface types, we have the events that play them. Fast will play the blend container for Foley, as well as the switch for the run footstep. And then the slow would play the slow blend container for Foley, and then the walk switch for the footstep. So this is all based on player speed RTPC. In the x-axis and the y-axis, we have the LPF, pitch, and volume. And the idea is the slower the player is moving, the quieter, lower pitch, less impact, hence the low pass filter. Conversely, the faster the player is moving, way over here, this is full sprint, then they'll go at 1200 speed. They'll have really high kind of crispy impacts that are louder and higher pitch. So the first thing I did in Unreal was open the animations and set up the anim notify keyframes on the epic character run, walk, and jump animation timelines. So they're synced to the moment that the character's feet hit the ground as such. To determine the RTPC player speed minimum and maximum values for Wwise, I used a simple script that prints to screen the real-time speed as a string. So you can see here for the anim notify play walk step, gets the surface type, and then it moves to print the string, which is the speed value. It gets the speed variable, which is a float, and then it prints it to the screen. Same thing for the run animation. There's no sound because there's nothing implemented, but this is how I determined the speed. So you can see in the upper left, it's about 200 for walk, and then run goes up to 600, and then sprint is 1200. To make sure that the correct sound was playing for the switch container, there is this function here that I created, get surface type. And the way that works is it shoots a raycast down 200 from the character's feet. And then beneath the character, as long as it's looking at the physical material down there, then it hits, returns that value, converts the physical material to a string to a name, and then it triggers the set switch in Wwise, returning that information and then playing the correct switch container for jump, walk, and run. Now that I've implemented all the Wwise events and blueprint scripts for their game calls, we're ready for the runtime demo. I have on the left the Wwise profiler to show the events in real time so you can follow along and see how they're synced to the player's current location and speed. Starting with walking on wood, and stone, and grass, Sprinting. Running. Walking. Same thing for jump. Jump in place. It's relatively quiet. Jump run. A little bit louder. And then jump sprint. That one's noticeably louder. And that's it. Thanks so much for watching, and feel free to email or Discord me if you have any questions. Always glad to connect with fellow game audio folks.